Hi, this is chapter 4 in my video series, and I want to talk about the photon. Um, I know that it's not easy to believe, and there are a lot of people that really don't ever want to believe. They don't want to, they only want to know the things that they know, they have facts about, or they don't want to think about the things they have to wonder about. But for me, it was different. I had to acknowledge that I had curiosity and that I had a quest to try to find answers. And I appreciated that I had a mind to do this. So in my mind, I realized that I have found believing in God as my creator is something that's pretty wonderful and pretty unique in some ways to me. I find that in the wonder of nature, there is the beauty and the glorification of God. And one of the reasons that I know this is because I can see this. And this chapter is on the photon, and this is about light. And it's pretty easy to see how science uses light. I mean, it's not just microscopes and telescopes. And if you want to talk about telescopes, you can talk about radio telescopes or IR or infrared telescopes. And you realize that science has continually used vision to discover. In fact, observation is one of the main things about discovery. The spectrum that they use to tell us what the elements exist on the stars is another part of the photons. And so is this so called redshift that helps us to understand that the universe is accelerating away from each other. So it's easy to see why God would use light for our visions and the things that we see in nature. You just have to look at the stars and your mind is filled with the wonder of creation, and we can look at each other and we can actually learn to appreciate all of this beauty that surrounds us. And this is what our vision does as God gave us this vision. Science, it becomes a little bit more difficult. I remember in my old days, I understood science by, studying intensity and used to tell how distant light is from us. They use that to tell us how far stars are now. But I also remember the electromagnetic radiation spectrum, it's called, which goes from what is that? IR, infrared, to radio. I think it starts with radio waves. Then it goes to infrared, to to visible light, to ultraviolet light, to X-rays, and then gamma rays. That's all part of the spectrum. Those are all photons at different wavelengths. And we understand this spectrum a little bit. The spectrum basically is what gives us the colors in the rainbow. And so, as an old guy, that's what I used to read about light, and it was fascinating. But today, light is looked at a little bit different, and it's a little bit harder to understand. The scientists today will say that a photon is an elemental particle that makes up light. And the thing that's strange about it, it's not like other elemental particles that we know of, and it has no mass, but it has energy and it has momentum. And it was basically thought of to exist as quantums of electromagnetic energy. This quantums what gives you this really strange feeling about it, because quantums of energy or little packages of energy is a hard concept to understand. When Einstein came up with his E equals mc squared, I couldn't understand that at all, because how does the speed of light figure into energy and mass? And then when they came up with these black holes, and the black holes basically are described as having such strong gravitation that light can't even escape from the black hole. And so you say, well, how come something that has no mass would be actually not able to escape gravity? Because that's what gravity is based on. So we look at the idea, you know that this kind of phenomena is kind of strange. And when you start thinking about the idea of no mass, and they come up with this little duality. It's called the idea that light is a particle and light is also a wave. So it's a particle wave duality, they call it. And that gets us even stranger and further into this quantum mechanics, if you want to call it. The idea of quantum mechanics kind of begins with this Heisenberg uncertainty principle. Light is called a virtual particle, sort of like what we usually talk about when we say there's a virtual computers. We're in a virtual reality, which means it's not real, and they call that light part of that virtual reality, and it's kind of hard to make sense. But even further, you have to go into the idea that Max Planck, who is considered the father of quantum mechanics, he created a equation for the energy of a photon, and he had to use what is called the Planck's constant. And the Planck's constant is so very, very small. That's why everything becomes virtual, because it's too small for us to even imagine. They describe it, in a certain way. It's sort of like when I talked about string theory and the 11 dimensions of string theory, and why can't we see these other dimensions? And the physicists will say you can't see them because they're too small, and that too small thing becomes a part of Planck's constant also, and his measure of the energy of a photon. They basically say that the energy of a photon is so small we can't even envision these kind of things with our mind, and we can understand small and visualize small, but not that small. And that's what happens with this. And I don't live in a virtual reality world. I live in a world where I see things that are real, and I can understand them because they're real. And so basically the wonder of God's photon and the way that it's used and the way that we understand it is one of the reasons that I can look at these things and believe that the things that I wonder about are best explained by believing in God. I need to talk a lot more about this photon, so there will be a part 2 to this message. Thank you.